I hope you guys are excited because I am. We're finally gonna do some real calculus. No approximations, no geometry tricks. We're gonna get exact answers for integrals. I'm excited. Alright, let's look at the first one. The integral from -1 to 3 of 3x squared minus 2x minus 1. The first thing you do is you do the antiderivative. So I'm going to use my power rule, add 1 to each exponent, and divide by it. So this is 3x, add 1 to 2 gives me 3, divide by the new exponent, minus 2x, add 1 to the exponent, divide by it, minus, here's what you gotta see about a constant. This is a 1, x to the 0. Anything to the 0 power is just 1, right? And so if I add 1 to 0, I get x to the first power. So this is 1 times x, so I can just put x here. Hopefully you got that from the first section. And I don't worry about the plus c here because I have limits of integration now. And so I'm going to evaluate this from -1 to 3. To evaluate it, you plug in your top limit, plug your top limit into your function, and then plug in your bottom limit and subtract it from the top limit. So I'm going to do first the top limit. So, oh wait, let's simplify this first before we start plugging things in. This is equal to x cubed minus x squared minus x. Now let's evaluate that from -1 to 3. I think our life will be easier now. Okay, so I'm going to plug in the top limit. So I have 3 cubed minus 3 squared minus 3. So I took this 3, plugged it in everywhere that there was an x, and I subtract from that the whole thing with -1 plugged in. So if I plug in -1 cubed minus -1 squared minus -1. And now it's just a matter of simplifying the math. So I have, what have I got here? I've got 27 minus 9 minus 3, which is 27 minus 12 is 15. Over here, -1 cubed is still -1. -1 squared is just 1, but I have minus that, so I have minus 1. And then here's plus 1. So those cancel out. I've got a -1 times this negative out front, so that's plus 1. And so my top limit minus my bottom limit gives me a total of 16. Done. No rectangles, no trapezoids, no approximations, no drawing pictures. That is the area under this curve between -1 and 3. I'm pretty excited about that. Let's do another one. The integral from 0 to 9 of the square root of x dx. First, I know that to do my antiderivative, I'm going to have to rewrite that square root so I can apply my power rule. So I'll rewrite that as x to the 1/2 dx. Now if I integrate, if I add 1 to 1/2, that's 3 over 2. So add 1, divide by it. No plus c, because I'm going to evaluate this from 0 to 9. Let's clean it up a little bit. I can flip that fraction over. So it's 2/3 x to the 3 over 2 evaluated from 0 to 9. The 2/3 doesn't change, so I can pull that out front. And then I can do my top limit minus my bottom limit. And then all I have to do is simplify. So this is 2/3 times, let's think here, I know that's just going to be 0. Let's contend with this. If I take the square root of 9, I get 3. And then if I cube 3, I get 27. Ooh, dropped my stylus. Don't be alarmed. So this is 2/3 times 27. 27 over 3 is 9. 2 times 9 is 18. Done. I love it. I hope you guys enjoy this. Let's do another one. Gotta throw in some trig. Let's find the integral from 0 to pi of 2 plus the sine of x. Start with the antiderivative. So this becomes 2x. If I go backwards from the derivative of cosine, I'll get to sine. So this is minus cosine of x. And I'm evaluating this from 0 to pi. So I do my top limit minus the bottom limit. And then it's just a matter of simplifying. So this is 2 pi minus the cosine of pi. That's the left side of my unit circle, so that's -1 minus, that's just 0. The cosine of 0, it's the right side of my unit circle, so that's +1. But there's a negative there, so minus +1. And so I have 2 pi plus 1 plus 1, so that's 2 pi plus 2. Done. I like these a lot. Last one, find the average value of f of x equals x squared plus 1 on the interval from 0 to 2. There's a formula for average value, and I just need you to commit the formula to memory. It's 1 over the distance between your interval, right? So it's 1 over b minus a, where this is a, b over here. So it's 1 over the distance of your interval times the integral from a to b of f of x dx. And here's how I want you to think about this. This is adding up all the y values, and then this is dividing by the total number of y values. And so if I take my total divided by the number, that's an average, right? I don't know if that helps, but it helps me think about it a little bit. So let's plug in the numbers that we know. 1 over b minus a times the integral from a to b of f of x dx. And this really isn't any different than what we've been doing. We've just got an extra term out front here, so not too bad. Let's go to the next slide and integrate. It's going to be, let's see, x cubed over 3 plus x. So out front I had 1/2, and then when I integrated I got x cubed over 3 plus x, and I'm evaluating that from 0 to 2. Keep your 1/2 pulled out. First I'm going to plug in 2, so I've got 2 cubed over 3 plus 2, and then I'm going to subtract, plugging 0 in. Always convenient when that whole thing is just 0. And so I have 1/2. 2 cubed is 8. And then plus 2. So let's think here. If I get a common denominator, this is going to be 6 over 3. 8 plus 6 is 14. Can you hear my dishwasher in the background? I'm really sorry about that. Where was I? Yes, 8 plus 6 is 14. 2 times 3 is 6. I can simplify that to 7 over 3. And we're done.